Everything is gibberish except this. I don't care to look anywhere. I summarized all the information in the table. I only need the table to graph my function. That's it. So here it is. When we graph a function with asymptotes, we have to graph the asymptotes first. So my colors are fading. Okay, so 1, 2, 3, 4, 5. X equals 5 is a vertical asymptote. This I should have written here also. Y equals 0 horizontal asymptote. It's an overkill because it's already there. But I'm going to graph it anyway. Okay, now ready. Let's look at the points first of all. 0 to 5th, so it's a number, it's a point here, and that's all I need. Ready? The function opens upward is increasing, starting close to 0, crossing the y-axis, and approaching infinity on the left-hand side of the vertical asymptote. Again, the function starts close to 0, increasing, opening upward, crossing the y-axis at 0, 0.4, continues to increase, opening upward, approaching infinity on the left-hand side of the vertical asymptote. Piece of cake. Done. On the other side, the function is opening downward, coming from negative infinity on the right-hand side of the vertical asymptote, and approaches 0, increasing, opening downward, again, coming from negative infinity, increasing towards 0, opening downward. Fine. And this is the graph of function negative 2 over x minus 5. Any questions on this function? Any questions on this function? You must understand how to summarize the information in the table, and you must understand how to use the table to graph the function. This is one of the core applications of differentiation. Okay, let's choose another problem. Any questions, please? Anything? Okay, let's look at one that is slightly more sophisticated this time, with more work, slightly more work. Okay, let's take a look at 43. And we have f of x, because I promised something like this last time. X squared plus 2x minus 15. Okay, good. So what do we need to do first? Of course, we're asked to graph the function. What do we need to determine first?
Would you factor out the denominator?
Absolutely perfect. Who was that? Thank you. Who was that?
Landon.
Landon, thank you. Can anyone factor the denominator for us? Yes, we need to factor the denominator because we need to simplify if possible, and also we need to find the domain.
Yeah, x minus 3, x plus 5.
Excellent. X minus 3 and x plus 5. Good. So what is the domain of this function? You can say in plain English, anything but. Anything but
3 and negative 5.
Very good. So negative 5, nothing underneath. 0 has to be in the table. 3, nothing underneath. Now I will simplify. Can I? Is there any factor that I can get rid of?
X minus 3.
Indeed. And now it's gone. And we are no longer working on this function, but we are working on this function. Because the factor of x minus 3 disappeared, x equals 3 is not a vertical asymptote, but a hole in the graph. The factor that remains still in the simplified form is a vertical asymptote. Can anyone plug in 0 and tell us what we get? Again, the same situation. I can never equal 0 because it's 1 over x plus 5. A fraction is 0 only when the numerator is 0. So can anyone plug in 0 and tell us what we should write under 0? Please. 1/5 indeed. Thank you very much. Excellent. Good. Now I need this. 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 And I need this. A lot. Now, from what we've discussed, what do you think the limit at infinities will be? Limit of 1 over x plus 5 when x approaches infinity or x approaches negative infinity. One pi divided by billions of people.
0.
0. So y equals 0 horizontal asymptote. That was easy. Painless. Good. Now let's see what happens left and right of negative 5. Limit Sx approaches negative 5 from the left, and limit Sx approaches negative 5 from the right. Again, negative 5 is here. Negative 5 from the left is negative 5.1. Negative 5 from the right is negative 4.9. So what should I write? From the left of negative 5 and from the right of negative 5. Anyone would like to try, please? Okay, the top is 1, and what is the denominator? The preliminary assessment.
Negative 0.1.
So you mean initially 0, correct? And with negative 5.1, it's a negative number. So then what is the answer? Perfect. You are ahead of me. That's good. So what is the answer then?
It would be negative infinity.
Brilliant. Thank you very much. In the same way, this is positive, so we get infinity. Exactly. Thank you so much. Okay, finally, with 3. So in this particular case, when we write the limit, Sx approaches 3 from the left of 1 over x plus 5, and then limit Sx approaches 3 from the right of 1 over x plus 5. What is the initial assessment when you plug in 3? What do we get? When we plug in 3, we get? Please, anybody?
1 over 8.
That's it. That's it. There is no undefined situation. That's all I need to write. 1 over 8 and 1 over 8. How am I going to plot 1 over 5 and 1 over 8? I don't know, but we'll make it work. Okay, done. There is nothing else I can find about the function from the function itself. Done. Now I have to discuss or study the first derivative and then the second derivative, and then I can graph. Okay, so like before, this becomes quite easy. So f of x is x plus 5 to negative 1. So of course the first derivative will be negative x plus 5 to negative 2. Remember, times the inner function prime, luckily, is 1. And then also the second derivative will be 2x plus 5 to negative 3, or 2 over x plus 5 to the third. Okay. None of them, they're not undefined. They're undefined at negative 5, but so is the function, nothing. They can never be 0, no critical numbers, no inflection point. But I need a sign. Can anyone tell us what is the sign of this forever and ever? So I can put it in the table.
Positive. Negative.
Yes, this indeed, this is always positive, but with minus in front, that tells me now I have to check, because I don't know. This is when I catch my mistakes. I don't know if these two rows work well together. I have to check. According to this, if the first derivative is always negative, what does the function do? Decreases at all times. If these numbers don't follow that pattern, I'll say, oops, and I'll start from scratch. From 0 to negative infinity, it makes sense. From infinity to 0.2, it makes sense. From 0.2 to 0.125, yes. From 0.125, whatever, to 0, yes. So these two rows are okay. Now I have to study the sign of the second derivative. I have to be careful. I have to pick a number to the left of negative 5. I will pick a number like 0, and I will pick probably a number like 10. Although, this is the key, either left or right. Okay, so let's plug in negative 10. So please plug in here negative 10. I need the sign, only the sign. I don't care for anything else. So if we plug in negative 10 in here, what is the sign?
Negative.
Indeed. Let's plug in 0. What is the sign?
Positive.
Okay. And of course, the same thing will be with 10, because the key is negative 5. This tells me that the function does not hold water between these two, and it does everywhere else. Done. Everything is gibberish. I don't care for anything. I only care about my table. This is the only thing I need. Nothing else matters. This is the only thing that helps me graph the function now. Okay, good. When I graph a function with asymptotes, I have to start by graphing the asymptotes. Yes, it's an overkill. I know you're going to say that. I'm going to write it anyway. Then I have negative 5. 1, 2, 3, 4, 5. They're not part of the graph. They have to be graphed as dashed lines. Okay. Now I'm ready to start. The function comes from 0, decreasing to negative infinity, opening downward on the left-hand side of the vertical asymptote. From 0, decreasing, opening downward to negative infinity. Easy. On the other side, 0, 1/5, I don't know. Tough. Here, 1, 2, 3, 1 divided by 8, I don't know. Somewhere, I can plot 0.125. Now I read the table. Opening upward at all times, decreasing at all times, coming from positive infinity, crossing the y-axis at 0, 0.2, going through an open point, through a hole, continues to decrease towards 0. Easy. And this was the graph of f of x, whatever, x minus 3, where is my function? Over x squared plus 2x minus 15. Only the table can help us graph. Yes, can you check this with the graphing calculator? Yes, you can. However, I caution you, the calculator will not tell you what you know about this function. It will not. So clear parentheses x minus 3 divided by parentheses x squared plus 2x and minus 15. Okay? So when you graph with, let's say, Zoom 6, if you copy something like this on a test, I can give credit. First of all, the graph does not show the open point. So please do not even bother. Just look at it just in case, you know. The function has to have a vertical asymptote at -5. And it does not show the open point. I can show it to you by going to Zoom. No, not to Zoom, to Window. And I'm going to say the x values should be between 2 and 4. And the scale, I don't care, but the y minimum is 0. And the y, no, that's not what I meant. The y minimum is 0. No, that's not what I meant. I meant 0. I meant 0. And the maximum, let's say 0.5. So I'm zooming in. And now you will see the blip at 3, right here. But the graphing calculator, initially on the standard viewing window, it will not show. Okay. Good. So I like to look at a word problem so we can continue. So in these situations, so if I assign a problem from here and it says graph V, I don't want you to spend the time on the graph on this. Why? Use the calculator. I'm okay with you on this one using the calculator. But again, you have to look at these values in order to find the appropriate viewing window, because you may not see it if you use the standard viewing window. But I don't want you to spend too much time on the graph, because these graphs are involving. I'm happy with simple graphs like the ones we graphed in class, which you will have to graph on the test and final exam. But on these problems, I will, when I put problems like this on the test or the final exam, I will not ask you to graph them, because the graphs will take 20 minutes. And that's not possible on a test. Okay, so let's look at a word problem and see what they want. Average cost, depreciation, total cost and revenue, cost of pollution. Let's choose a problem so we can finish up section 3.3. Value of a stock, sales saturation, medication in the bloodstream,
Can we do 59?
59, the medication in the bloodstream. Okay, perfect. Let's do that. Good. 59 is on what page? I think it's 306, yes. Okay. So we're given a function which is a of t equals a0 over t squared plus 1. What type of function is this? A number over t squared plus 1. How do we call it? Very important to identify what it is. What is it? Is it quadratic? Is it logarithmic? Is it exponential? What is it? Can anyone tell us what it is? Please.
Quadratic.
It's a ratio, right? If it's a ratio and it has the variable in the denominator, it has to be rational. This is exactly what we just looked at, right? It looks quadratic because you see t squared plus 1, but it's a ratio. A quadratic equation and function cannot have, those cannot have a denominator with a variable in them. Okay, so after an injection, the amount of medication A in cubic centimeters, I take notes, cubic centimeters in the bloodstream decreases with time t in hours. T in hours, perfect. Suppose that under certain conditions, A is given by this formula, where A0 is the initial amount of medication. Assume that the initial amount is 100 cubic centimeters. So our formula is basically 100 over t squared plus 1. Okay, moving on. Now let's see what they want. Find A of 0, 1, 2, Find the maximum amount of medication in the bloodstream over the interval 0 to infinity. Graph the function. Yes, this one we can. This one is not a problem. And according to this function, does the medication ever completely leave the bloodstream? Explain your answer. Okay, so first of all, I'm going to put the function in the graphing calculator and then punch in immediately 0, 1, 2, 7, and 10. So in y equals clear 100 divided by t squared plus 1. Always enter the function and then quickly determine the numbers. 0, 1, 2, I think it was 7, and I think it was 10. Let me check. 0, 1, 2, 7, and 10, correct. So I'm going to, the best thing to do is just create a table or just write them down. It's up to you. I'm going to create a little table. So I have t and I have a of t. So 0, 1, 2, 7, and 10. For 1, I have, of course, 100, and then I have 50, and I have 20, and then I have 2, and then I have 0.9901. Okay, so that part is done. Then find the maximum amount of medication in the bloodstream over the interval 0 to infinity. Okay. So when we look at a prime of t, which is, I'm going to put a question mark first because I want to change it into 100 times t squared plus 1 to negative 1. So let's see how we find a prime of t. I bring down negative 1, multiply by the function to negative 1 minus 1 times the inner function prime. Can anyone tell us what is the inner function prime? The inner function prime is?
2t.
Excellent, thank you so much. So negative 200t over t squared plus 1 squared. Perfect. So I have t 0 to infinity, they are telling us a prime of t and a of t. Good. So we have to find critical numbers. So a prime of t can be 0. 200t over t squared plus 1 squared can be 0. When t is a fraction is 0 only if the numerator is 0. So for which t value or value of t is this numerator 0? Only when?
When t is 0.
Exactly. So the only critical number is 0. Now, remember t is a positive number. What is the sign of this whole thing? Forever and ever. Positive, positive, positive. Forever and ever, what is the sign of this expression, which is the first derivative?
Negative.
Of course, always and forever. Positive, positive, positive with minus in front will be negative. So as they already told us from the beginning, they already said the function is always increasing. Then this must be the absolute max value. There is nothing else. So the maximum value is, as you already see it here. So at the time t equals 0, when I take the medication, the concentration in the bloodstream is the maximum. An hour later, it drops to 50, 2 hours later to 20, ta, 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 ta. So this is indeed the maximum, which is 100. Since the function is always, since the derivative, first derivative is always negative, the function is always decreasing. Now, if we look at the function itself, and you want to determine the limit, because we need to, I need to fill in the table. The table has to be filled in. So I need this number here, or whatever it is. So I want the limit as t approaches infinity from the function 100 over, this is our function, 100 over t squared plus 1. What is this answer? Always remember, a tiny number divided by billions. What do I get?
0.
Excellent. So 0, y equals 0 is a horizontal asymptote. So this is the maximum. The function is decreasing, getting closer and closer to 0. So when we say closer and closer, at the question that we see here, it says, according to this function, does the medication ever completely leave the bloodstream? Theoretically, it does not, because we say this may be attainable. May be attainable. So this is not a complicated situation to graph, but just for the sake of the argument, oops, I didn't share, sorry. So let's just graph it with the graphing calculator. So obviously I want 0 to infinity. I'm not going to use infinity, I'm going to use 10. So the function can never be negative. So I don't care for y minimum, negative 10. I'll put negative 2 so I can see the x-axis. And the y maximum is 100. So I'm going to write 120 because I want to see a little bit above, and I'm going to use a scale of 25. And now I click. Here it is. So the maximum is at 100. It has a inflection point. We didn't calculate it. We just went ahead and graphed it. So it has an inflection point, as you see, opening downward, inflection point, opening upward. No, the function does not touch the x-axis at 10. No, do not copy something like this, please. It's getting closer and closer. We identify the horizontal asymptote. Okay, any questions on this problem, please? Any questions?